Hello, this is a video for EDX Statistics 1. It is the final video in this series and will cover linear combinations of random variables. To begin with, let's consider what we mean when we add two random variables together. In this question, we are asked to find the probability that a value from x and a value from y is equal to 2. To do this, we consider all the possible ways of making 2 from x and y values. So either we have that x is equal to 0 and y is equal to 2, or that x is equal to 1 and that y is equal to 1. And all we need to do is to find those probabilities and multiply them together because they're independent. So these probabilities multiplied together give us 0.4 times 0.6, which is 0.24, and 0.3 times 0.4, which is 0.12. So the probability that x plus y is equal to 2 is all of the different ways added together, so it's simply going to be 0.24 plus 0.12, which is 0.36. We can extend this idea to expectations, and therefore we can say that the expectation of x plus y is equal to the expectation of x plus the expectation of y. And we can extend that even further still and look at the expectation of x minus y and the expectation of ax plus by. And this comes from the result that e of ax is equal to ae of x from a previous video. So this can work for more than two variables, so 3 or more variables. You can still add them together, you can still multiply by constants, and you can create combined expectations in this way. So a couple of examples. We've got two discrete uniform variables, x and y, and because they're discrete uniform variables, we can find the expectation of x and the expectation of y fairly quickly by using the formula n plus 1 over 2. So the expectation of x is going to be 7 plus 1 over 2, which is 4, and the expectation of y is going to be 11 plus 1 over 2, which is 6. So to calculate the expectation of x plus y, we simply find the expectation of x plus the expectation of y, which is 4 plus 6, which is 10. The expectation of x minus y is similarly 4, take away 6, which is going to give me minus 2. 3x plus 2y, well, I'm doing 3 times the expectation of x plus 2 times the expectation of y, which is 3 4s, which is 12, plus 2 6s, which is 12, and that gives me 24. And on this final one, I've got 3 different observations of x, so 1, 2, and 3. All of those have an expectation of 4. And 2 observations of y, both of which have expectation of 6. Add all of those together, and I get 24. Now in this instance, both of these numbers are 24, but as you'll see later in this video when we do this for variance, both of these two numbers will not be the same. There are those calculations typed up. When we look at variance, we need both x and y to be independent of each other. And that means the occurrence of one doesn't affect the other. So the value that you get for x doesn't affect the value you get for y, and vice versa. And very similarly to the expectation, the variance of x plus y is the variance of x plus the variance of y. But we need to be a little bit more careful about this, because if we asked what's the variance of x minus y, it is slightly different. And that's because we know that the variance of ax, or variance of ay, would be a squared times the variance of x from a previous video. And so here, where we've got minus 1 times it, that still remains a positive. So the variance of x minus y is still the variance of x plus the variance of y. It can, however, still be extended into other situations where you have ax plus by, that would give you a squared, the variance of x, and b squared times the variance of y. But no matter whether it's a plus or a minus in the middle, it will always be an addition of variances. So to do an example with the variances like we did with the expectations, we will need to know the variance of x and the variance of y. So the variance of x is going to be n plus 1 squared over 12 because it's a discrete uniform variable, and this is going to give us 16 over 3. The variance of y, calculated in the same way, gives us 12. So now when we calculate the variance of x plus y, we're going to get 16 over 3 plus 12. That gives us 17 and 1/3, or 17.3 recurring. And the answer for the variance of x minus y is going to be the same, because you never subtract variances, you always add them together. This is going to give me the same answer again. When we multiply by a number, we have to remember to square that number, so it will be 3 squared times 16 over 3 plus 2 squared times 12. And this is going to give us effectively 3 times 16, which is 48, plus 4 times 12, which is also 48, which gives us 96. Now when we do this with different variables, and notice that this is a slightly different question to the one above. This is 3 times one particular outcome, if you like, from x, or one particular variable. These are 3 different observations of x, and therefore they vary slightly differently. But the variance of x, which is 16 over 3, plus the variance of x, which is 16 over 3, plus the variance of x, which is 16 over 3, plus the variance of y twice, is going to give me, well, that bit there is 16 plus 24, which gives me 40. And therefore you're getting different answers when you triple a value as you do if you're taking independent different observations of x. And there's those ones typed up. So notice that this has been summarised to 3 times 16 over 3, rather than writing 16 over 3 out 3 times and adding them up, whereas this one is 3 squared times 16 over 3. Okay, similarly 2 squared times 12 and 2 times 12, depending on how the question is asked. So that's a really important thing, and it's really important that you make sure you know what the difference between those two things are. When you do n times x, you get n squared of it. If you're simply doing n different observations, you are only doing n times it. The final note to say on this video is just to say that whilst we did combine 2 uniform variables in these 2 examples on this video, the resultant combined distribution in each case was not uniform. So that's the end of this video, and this is the final video in this series.